Let's get started on the slides and get the presenters going here, right? Welcome everybody to the second quarter meeting of OWASP San Antonio. If you're not familiar with OWASP San Antonio, we're a growing chapter. We restarted this chapter about, what is it, a year and a half ago, guys? A year and a half ago. And as you'll see later on, we're above 500 in membership now. We started from zero again, and in a year and a half, we're above 500. So it's going really well. We have some exciting topics to present today, so let's get into it. All right, so we had our network tabletop discussion. Our first presentation is going to be how to engineer supply chain controls. Then we're going to have one on threat-informed defense. One on, we're going to take a break. Then we're going to have one on AI attack storm, security at machine speed. Then supply chain threat we're not ready for. Then we're going to do another break. And then we're going to do a security panel. And we're going to talk about kind of the trending risks for supply chain security and how potentially addressing those risks. I'm sure AI might come up there, right? And so, and then we'll finish up with future meeting topics and some other slides. And then the best thing is then we'll break and then we'll start our networking happy hour. You have some tickets. We're also going to do a raffle. So you should have a raffle ticket. We've got some great prizes today. I wish I could win one. I mean, there's some real over there. So hopefully you'll win a prize. And then you should have 2 drink tickets. I would ask, please don't share those drink tickets in past events. We have people like collecting drink tickets from other people and having like 8 drinks. And it's like, we don't need to get in trouble here, you know, yeah. So don't share your drink tickets. If you're not going to use them, just give them back to Ari or Donna, the greeters at the door. That'd be great. So that's our agenda for today. And let's go to the next slide, please. Okay, so event sponsors today. We have during networking a happy hour. The event sponsors have demo tables and tables where you get more information on their products and services. So please, as you're drinking your wine, you know, enjoying your drink, stop by and say hi to them later on. They make events like this possible, right? So this is our board. I'm the president leader for the chapter. Brent Doherty, he's not here today. He handles the vendor engagement and sponsorship, along with Rodney Fielding, who does a lot of the communications as well. And then we have Canvo for communications and media, Diego, Zori, you know, so it takes a lot of folks to make these events happen. And one of the things that is unique about our event is we not only do in person, but we have people on virtually right now that are listening in to the presentations as well. So we do both. Okay, this is where we'll ask, is anybody, any companies here looking for folks? If you're looking for folks, you could stand up, tell us about the position you're looking to fill. And you might get lucky. Who knows? Might be someone here looking. Yeah, sure.
Yeah, it's not quite posted yet. It's not quite posted yet, but my team, incident response, is looking for a level 1. It'll be posted within the next few weeks. Security information analyst.
Great. And that's with Frost. And great company to work for. I work for Frost, so we'll put a little plug in there. Any other companies looking to fill some positions? Anybody? No? Okay, and then we'll ask anybody looking for positions. And if you're looking for a position, please stand up, tell us the position you're looking for, give us a little bit of your background. Anybody? Sure.
Hello, everyone. I'm Kevin. Um, right now I'm an entry level help desk assistant. In particular, I've only had only 1 year of experience working, but in particular, I'm looking for entry level SOC analyst positions, or any type of work that involves dealing with blue team work. A little bit about my background. I don't have any particular educational background in IT, but I do have a certification in Security Plus, and as well as a cybersecurity boot camp certification. If I lack experience, I'm very much willing to learn if possible. If anyone is come after the meeting is over.
Good to see you're taking the initiative to get those certifications. Very good. Anybody else looking for work? Okay, great. Let's go to the next slide here. So what's our charter? So we're focused, OWASP is focused on application security, but we have other topics that we integrate. But it's really around best practices, standards, policies, you know, how can we get better at building secure applications, right? We also try to help folks in terms of training and training opportunities. And of course, the networking side of things, which we're going to be doing later today. You know, collaboration is very important across industry. I learned a lot about, a lot from other folks that are facing the same problems that I'm facing at any time, and applying best practices from that. All right, and this brings us to our first presentation, how to engineer supply chain controls. Tim Gowan, Success Architect, Endor Labs. All right.
All right.
This is use it to advance it. Okay.
Oh, okay.
We'll get you set up.
Just only the supply chain of my attire.
Do you have a special hat? What's the dance to the fight? It's the middle quote. Oh,
Thank you. All right, well. Okay, so starting with the story here, in 2015, about 10 years ago, I was showing up to my second job at Verizon Maintenance Engineering. I was hired there through a church network colleague or a friend, and the directive was pretty simple. It says, we've got test cycles that we need to accelerate from a matter of weeks to a few days or less, because we need to be able to work through and keep up with the pace of our 5G rollout that's coming up around the corner. I'm like, sure. That sounds very simple, or relatively easy to do. I've done this kind of job before. I know the software tooling that I wanted to have and how to build it. So I was studying it up before even starting on the job. So first day there, I'm like, okay, where do I go to get my software and the tools that I need? Saying, okay, everything needs to route through IT. So I asked them, these are the things I need. I want Python 3.8, which is cutting edge at the time, and took 2 weeks or so to even get back, and the answer was no. And that's when I learned I realized the mistake, or thought the mistake, that I had to unlearn for the next 10 years. that, these security folks, I thought to myself, are costing the business tens of thousands of dollars in automation savings for every single week that they're keeping me from the tools that I need. So, the mistake that I spent 10 years in the learning, at HPE, we're decomposing monolithic applications into microservices. It was from the same cloth, and we split them up so that it's managed by different teams. And over there, I still thought, security, operational costs. Same thing at Verizon. We were trying to optimize to the fractions of nanoseconds for these packet processing throughputs. I'm like, security, cost of doing business. We got to have firewalls. We got to inspect the packet. Operational cost. Then things started to convert over at Sneak, where I worked with actually my colleague Jay over here, who's going to give the talk after me. They were part of this shift left revolution, where they're bringing in the alerts over to the developer machine. The developer can decide which packages are secure and which is not, which ones do I want to engage my application. But really, all we did was shift the alerting left. We didn't really shift the governance and controls left. All right, now brings me over to Ender Labs, where I'm now squarely in the camp of pillar of engineering, that we need to rethink about how we do supply chain, how we do supply chain controls. And so the rest of this deck is more of a stream of consciousness backed by evidence and backed by some data that I've derived from a little bit of math, a little bit of live customer metrics that have been anonymized, and walk you through the framework or the blueprint that should be portable, vendor agnostic, and works to control this at scale, no matter what your enterprise estate looks like. These are statistics. I was trying to make it as conservatively calculated as I could. It's napkin math. Y'all can do it. And if you get the deck afterwards, there's citations for every single part of the math. But we're thinking of the average organization and normalized by the number of developers in that organization. We get these simple calculations. You get 125 findings per developer per year of actionable alerts that you have to solve. It's just an average statistic, right? 125 tickets, potentially, 125 cycles back and forth. And I realize this is more of I'm framing it as a computer science problem. There's this concept called a CPU thrash, where the time it takes to execute a process is longer because it has to go through a slower route due to the resource constraints of the system. I feel like it's the same thing, and hopefully the talk will make that point for us. How do we get here, right? What is the problem? And the phenomenon that you guys might have already heard is this concept called dependency sprawl. Everyone knows, but a phenomenon is more of a struggable thing. It's like, oh yeah, we accept it because it's a thing that exists. But what I wanted to do was attach a metric to it. The metric that I've landed upon is version cardinality. That in plain English, it's how many versions of a single package do you have to babysit in your ecosystem at a given time. Right? What we have here is a curve sorted by order of consumers in a company. Think about, of the 350 versions of Jackson Data Bind that are published in the Maven ecosystem, they use 140 different versions. Sorted by the number of consumers, you see the gradient curve. Most people are doing fine, upgrading to the later versions. But you see this long tail, and I've color-coded a single critical CVE to demonstrate that even if it's just one security issue
with one dependency. When you're thinking about it from this dimension, you've got 236 critical findings, AE tickets, and 52 different upgrade paths to manage across your entire estate. And how do we get here? When I'm thinking and reflecting, how does a developer operate? We see, or it's a misalignment of priorities. Some developers who are security conscious say, I'm going to pin my versions. I don't want any breaking changes. I want to know exactly what I'm building and what I'm putting out there at any given time. Other developers might be like, I want to set it and forget it. I'm working on a service that's internal. If it breaks, no big deal. I'll just rebuild it, fix it, move on. So you get this disparate behavior and a degree of autonomy siloed at each individual service or developer team. When you don't have the organization, you get to a certain sprawl because people get to choose, people get to pick. It's just a compounding effect of entropy or sprawl. And if we tie it back to a more recent events around supply chain security, the Shai-Hulud worm, what they exploited was not a certain vulnerability, but of like a package or an application. They exploited a vulnerability in our engineering processes. Right? Some people choose, and when it comes to selection of packages, sure, maybe some folks pin it, but who's to say that the maintainers themselves can pin their own applications, or pin their own dependencies? So you get this compounding effect. Entropy on top of entropy. How do you calculate version cardinality? Very simple. Right? About 5 bullets. Turn it into a recipe form for some flair. And what you do is you have a set of dependencies. Most of us are familiar with the concept of SBOM, where you understand the components built in your applications. You just do some scripting to understand, okay, these are all of the dependencies in my estate. You export the dependency tree by the number of instances it appears, and you start aggregating them by the versions that are in use. Right? You land on a simple tuple of three fields, and then now that you sort them in order of the number of consumers, you get that same exact graph that I showed you, and then you can layer on however many CVEs you want for risk-based prioritization and analysis. And I say that with the transitive dependencies are optional in some cases. In many cases, they aren't because of policies and regulations. But certain ecosystems provided here that looks like kind of a nutritional chart has this weird amplification effect. Java being the worst offender when it comes to dependencies. The developer only selects one package, but Java might, and those packages on average, pull in 24 different other libraries downstream. Different for every ecosystem, but you have this additional effect of compounding and yet again, another source of entropy in your system, a broader surface to protect and manage in your estate. Hence, you get the version cardinality problem you saw earlier. So straight to the solution here. How do hyperscalers do it? Right? When we're considering an estate, Google themselves, they have around maybe 20 billion lines of code, about 10,000 developers during the time when this metric was taken, and only one version of each package used across their entire ecosystem. That is the biggest code base in the world, has the absolute floor of version cardinality. And they do this because they work out of a concept called a monorepo. If you're not familiar with this term, it means all of your code exists off of one Git repository, one link, and they get to control all of that within the bounds of that ecosystem that they built out. It doesn't always follow that form. Meta follows something similar, but they have a singular dependency tree. They're trying to enforce a mono versioning standard, but they have different tooling to manage it and different things that work for them. But if you think about it, YouTube, Google search, Drive, one estate, one dependency per ecosystem for all the consumers. Meta, similar concept. And it's not always in that singular structure either. Provided alternate examples of other companies. The one I wanted to call out was Atlassian. They use monorepos, but they're isolated on a per product line and a shared interest domain. For example, they have a monorepo for all of their front-end components. So everyone consumes, if they have a front end, from that one monorepo. And that's how they control that family. Likewise, for every single product, if you're familiar with Jira or Confluence, their product lines are isolated into monorepos, and they can control that within a shared interest domain. When we're talking about the vast majority of folks, it's not always realistic. The folks that I've talked to, several dozen or so directly around how they're managing their estate, how they're building their software. We all land typically in the polyrepo bucket, where each team or each product line has autonomy over their own ecosystem, only considering what they're interested in and only optimizing for their own application set. And I drew these two diagrams just to showcase or kind of parallel to the throughput optimization pattern that I got from Brad. What we did was centralize the ingest and do the processing and compute once for packet inspection so that all downstream services can use that cache information. The same process applies here. When you're thinking about how a normal polyrepo estate works, if every single team is managing their own intake, managing their own upgrade and maintenance procedures, in some cases in tiny silos, you get a sprawling problem, and you're deeply inefficient in how you want to solve that and how you can solve that. So if there's anything to take away here from this slide, you can compare it to two fundamental philosophies around autonomy versus organization. When you're fully autonomous, you're optimizing for a local efficiency gain where the developer can choose and select and manage themselves, but not thinking about the bigger picture of what that cost is at a global level. Being honest with you, not all of us have a monorepo. That is the trends in engineering is climbing because there's a lot of benefits out of operating out of a monorepo that an engineering organization or team can appreciate. But the problem becomes, what are some properties we can take from the monorepo structure that we can extrapolate and apply to how we think of our engineering teams? It really boils down to two primary pillars. I consider these foundational to any attempt at managing or engineering your way through software dependency sprawl, which is the first one, executive ownership. Ownership of your inventory and an inventory of your own. Find not a team, but a person's name, preferably a stakeholder or director and above role or title in your engineering team. You make sure that they have ownership. They know that they know which ones are actively developed and which ones aren't, and the ghost ships in between. Active in your production environment, but not within your developers' hands. You know, things that are just running, don't if it ain't broke, don't touch it. And it's kind of off the typical Sprint side. Then you have three options when it comes to security issues and fire drills. You can either fund it, i.e. allocate resources to it, get a approved risk waiver so that you can have some degree of collaboration, or you kill or archive the service. You know, you just say, we're decommissioning it, moving on. The other pillar, the other property that we must have out of the whole monorepo structure is the centralized ingest control. You don't expose your mission critical resources and assets to the open internet. Why are we doing the same within the developer footprint, the set of supply chain controls situated with ecosystem, right? There's enough tooling out there. If you have a private package registry, if you're controlling out of the DMZ, and this isn't supposed to be a policy document that you're waving around. This should be a hard network boundary enforced at the network. You know, policy is code. If you can build it into your firewalls, that's the way you do it. So nothing enters your environment, nothing enters your network without someone approving it and validating that it works. With these two properties, we can start scaling out. And it's not going to be immediate. Incremental progress is almost guaranteed here. I put the Microsoft example out there because it took them 3 years of planning and 3 months of execution to migrate their 40 different silos that comprise of Windows into a monorepo. Planning is getting started. Planning is the activity that gets you to a state where you can engineer supply chain controls. Right, they tried a federated approach as well, and it failed because of more churn, and it wasn't quite the structure that they were expecting, but they were optimizing for engineering constraints. We were really only concerned in the security side of the security constraints. But putting a pin in the engineering value, because what this gets you, once you start to organize your estate, 3 different pillars. When we were rolling out the software infrastructure for 5G, we delivered these things called methods of procedure. Some folks who work in telco may be familiar with that term. It's effectively a written document with a payload of scripts or configuration files. Because at Verizon, they realized when we're managing hundreds of data centers globally, you don't want the same process to be owned by the engineering street level, technician to decide how to upgrade things. Those methods of procedure is effectively a pre-computed form of an upgrade. It's how to manage the scale of a wide distributed infrastructure set. And Verizon was able to do that and execute the 6 nines reliability. That means the uptime of 99.9999. However many, 6 nines. All right, this property can be inherited and can be done at scale. When we're talking about a controlled ingest, again, shifting left is insufficient because once you have it, if you're just putting it in a developer's hands, you're still trying to gate at every single developer's workstation. When it comes to malware, as soon as one developer gets hit, all of their credentials need to be rotated. You have to do full analysis and tracking the impact of the blast radius. Like, what are the credentials stored on that developer? What do they have access to that could have been exploited at that given time? When we're talking about the complete dependency graph, this is the most interesting part of taking it from value of an engineering perspective. when you have that completeness, you can pre-compute a lot of the testing efforts. For example, when Atlassian started to operate in this model, they had a blog that described how they saved about $40 million in their CI times by pre-selecting certain tests to run only when a dependency that affects that test is changed. So there are benefits here from an engineering cycle. And I've given you, again, the citations and links and examples. Shopify, Spotify. There's a lot of cases out there that describe from an engineering perspective why this model works for them and why they moved in the decision-making process behind it. Now, the incremental approach, the way I see most teams fail when they're trying to manage their dependencies is that they're trying to target the current seed. When they're taking in a certain affected version, they're targeting the latest version of that package. All right, that's almost a guaranteed non-starter for an engineering organization because the semantic versioning implies that they might hit breaking changes. But what I'm proposing is that you do a local flattening effect, where you select at the latest patch version available as an incremental approach. That way, what we're optimizing for is to minimize the version cardinality to a smaller number. And what you'll see in the data is that we're getting from 140 different versions to manage. We flattened it down to 24, which is an 8% reduction in that version surface area to manage. And when you're thinking about the number of independent breaking change analysis that you have to do, or the break fix operations that engineering has to do, goes from 52 to just 5. I'm going to argue with myself for a little bit because you can't be a good security engineer without really just, poking up the vulnerabilities in your presentation. First of all, semantic versioning, a bit of a lie. There's other, OSS maintainers, they're humans. They might not always increment the right number. And there could be things that don't account for a breaking change that you still want to know about. For example, changes in default values, changes in performance metrics of the dependency. My response to that would be that when you don't audit the number on the version, you audit the logic. You can take the difference, if you've ever heard of the term diff in engineering, you can take the diff of the files themselves, the code contained therein, or something a little more deterministically generated, like a dependency tree or a call graph. You can take the diff and understand what that difference is. And then it's hard to see here, but this is from a vibe coding session that I've had a few weeks ago. I asked for a library to process large data sets, and Cursor responded with searching for packages out of 2024 because its training set was from the 2024 period, which means when I asked for the latest, I thought, I'm just going to search for the latest package or packages around 2024 that are popular. It's when we think of AI and how it affects our work in the engineering and engineering side, it's a double-edged sword. You have new threat vectors like slop squatting, where malicious actors see that their LLM has hallucinated a dependency name. Like, great, I'm going to register that, publish my malware, and any other user of this LLM will land in the same way. But there's also some benefits. Like I was playing around, I'm realizing, you know, AI has advanced a lot in its programming capabilities, like 80, 90% able to generate functional code that's built to spec. You can ask a problem, you can ask an AI, you know, for this package, for this security issue, I want you to upgrade from A to B and fix anything that breaks. But think about the shape of that problem. For every single repo, for every single package and vulnerability alert, you're asking an LLM fix, you know, upgrade and fix, upgrade and fix. Compounding effect, it's an unbounded cost to remediating security issues. There's no limit there. But I cite an example from Google where you can build both, use the deterministic tools, deterministically generated artifacts to ground the AI to a certain process and procedure. And that's how Uber migrated their monorepo across 2 languages by having a coarse-grained approach to migration and to solve the little gaps, cracks that appear through LLMs and AI. And then finally, OSS maintainers, they work for free. You know, they don't really owe us anything. They give out their tooling, they give out their code and their brains for all of us to use. And saying, hopefully the OSS maintainer will patch it, it's not really a remediation strategy, right? So my response to that would be, own it. You know, you can take the package, wrap it around an in-house function, and that's the version that you publish to your team. If there's a SQL injection vulnerability somewhere in that OSS package, you build a wrapper that parameterizes all the queries and enforces that at the consumer. Or you fork it, you fix it yourself, and then if you're a nice person, you publish it back upstream, open a PR so that other folks can benefit from that. And you know, just to help you peek behind the curtain during the 2 years I spent as a pre-sales engineer at Sneak, and really you want to be able to frame the problem and frame it as a call to action. And the blueprint and really the biggest bottleneck is usually a conversation with your engineering leads and your engineering stakeholders. So I gave you a blueprint on how it works. First, you start with a problem. You frame it, you express it. You say, this is a friction point. Look at, you know, without going into FUD or too much FUD. You say, here's a problem. You empathize. You lead with the language of their pain or their friction and their problem. Then you identify or come to a consensus by constantly asking why questions until you find one that you both align on. In our case, is that this is an organizational thresh issue. Everyone is optimizing for their own local efficiency, local speed. And you get to the item number, the systemic solution. How do we solve this in a way that works for both of us? You trade, you know, you up front, be honest. Say, I'm going to trade my local, you know, efficiency so that we can get global macro velocity, right? I'm going to trade my developers' ability to select and manage their own versions so that the whole engineering department and the security team can work together towards a means that solves both sides of the problem. You know, just to be current, you can sprinkle AI in there and just to be topical that there is a compounding effect of everyone using AI that, you know, maybe your HR team is now building more code. I myself can work and manage accounts, but also have an LLM code stuff and side projects and run these kind of analysis on the side. The floor of knowledge has risen to the point where certain methodologies or processes that may have seemed out of reach in the past is a lot more accessible. And then finally, you close with a call to action, because this is something that you can, you know, execute Monday and work through and and build out. Really, the only bottleneck is getting started and having that initial conversation so you can start planning a road or a path towards reducing the dependency sprawl. And yeah, I am a success architect at Indoor Labs. You know, but I'm gonna be honest, you don't need our tool, because any SEA tool will get you there. You just need a way to pin your dependencies, centralize the ingress, have ownership, and you can execute the same playbook. Yeah, I'll be over there, and if you want to come say hi.
Actually, we want to open it up for questions first.
Oh,
And I have the first one.
yeah.
So when I'm looking at implementing a monolithic repository like this, what does it look like in terms of you have multiple products that are released at different times and multiple releases? How does that all get managed from the monolithic repository? I'm just having a hard time understanding.
You want to be able to hook it into your cycle, right? It's not about boiling the ocean. It's about having an incremental strategy towards solving that. When we're talking about the flattening approach with the patch versions, those are typically non-breaking changes that are, and if they are, relatively easy to solve for because they are trying to maintain as much of the functionality contracts as they can.
Mm-hmm.
But when you're talking about the coordinated aspect, maybe the temporal alignment aspect,
Right.
are you building those systems in a coordinated effort, as in a lot of different microservices and different timing cycles? Because when you're talking through an engine AppSec perspective, you could say, okay, in 6 months, we're going to deprecate the lowest non-flattened version of these dependencies. You have some time between now and 6 months from now to upgrade the patch version to the latest minor version in use, or and give them that leeway to decide when is an appropriate upgrade time to align with those cycles. But you have to have a process to control it so that developers can't just pull that dependency of whatever version that they're selecting, has to enter somewhere and be governed at a centralized location.
Okay. Opening it up for questions for the folks here.
Fantastic talk. Thank you for sharing. Really appreciate it. If you're going down this approach, how do you think about any of the remaining indirect or transit dependencies and the risks associated? So if you, even if you have the version flattening and the mock repo and the developer, including latest or post latest, you mentioned on one of your slides, like Java, for example, pull down 20 or 30 other dependencies, those could be out of date. Do you ask the developers to pin and override those, or do you just consider that accepted risk, or how do you deal with that?
This is the interesting part. You're getting into very, I'm fitting this question, to be honest. When you are pinning and exporting a certain artifact into your ecosystem, you're already, let's say I want to pull in Spring Library or Spring Framework into my app, and you've cached it at your ingest layer. That artifact is static from that point on, and that will always work within that ecosystem for all the consumers. You have, instead of a, when you think of transitive dependencies, when anybody can resolve them and decide during build time how they get resolved, the transitive libraries become a bit of a quantum state where it could be any number of versions in between, because it's tied to the time that it got resolved, the time that it was built. But if you cache the entire binary or the whole artifact at once within that constraint, you know that they'll be interoperable, and you can converge to a single tree for every single direct dependency version. Yeah.
Packages, but there's also, and I'm not sure if this would include additional mitigations you might have to apply to address the risk of rogue packages as well. So I'll use what's it called? XZ utils, that scenario, where that one was a multi-year campaign to compromise the repo itself and take it over. Would that pose any additional risk, or would it be addressed similarly to this, to just vulnerable packages?
So it was an infiltration over a long period of time. Did they deliver the payload and pull the trigger at a certain event, or was it distributed payload?
So-
would be hiding under the covers for a long time.
For that one, it was they released the vulnerable version into test first before it hit the production pipeline. And some nerd at Microsoft caught a millisecond level delay is the only reason why it was caught. But in this case, it was just a rogue package.
A rogue package, but the event happened. There's some dwell time between the payload being sent and the discovery. That'll always exist, but there's new concepts around this sleep period. Basically, you don't take within, most malware is caught within what, two hours or a few days. I think the longest one we saw more recently was the Peace Not War, which took a few months because it was a trusted maintainer, and it only affected certain geographical regions. You have a policy that says anything newer than X days before anyone could catch it gets blocked. So you're not always taking the latest. You take a safe version a few months back. That's, I think, a acceptable trade-off, because before, maybe security wanted the latest versions all the time when you trusted the OSS. Now with the NPM wave, I think everyone's realized the latest is not a very good idea. Just have a dwell time. I don't know what the time was for the XY.
It was pretty close because they pushed it to test. It got caught pretty quick after that because of some neurotic developer, but yeah, it was very lucky catch. But once it hit prod, it would have infected everything that used it, which is a lot.
Once you do centralize your ingest, at least you can control what policies govern the intake, whether it needs some manual vetting or some dwell time between publications.
That makes sense. Thank you.
Other questions?
Yeah, I appreciate you going through that. That was very well done. The Microsoft example, it kind of reminded me of I think it's Abe Franklin adage of spend the first 7 hours sharpening the axe, the 8th hour actually hacking out the tree. I think you said 3 years of planning, 3 years of execution to migrate. If that were done in 2026, how long would you speculate those same exercises were? We'll just use Microsoft as the same example to have an apples to apples comparison. Purely speculative, because I know it's impossible to answer.
Then it's purely speculative upon your budget. You can buy patches, you can hire, consultants to build it for you. You can pivot to new tooling that allows you to do it faster. Or you hire engineers to do it yourself. There's a lot of different ways this cookie crumbles, and I'm careful not to toe that line, because every single company is different, with operating with different constraints. How much tokens are you willing to spend, or what's the limit on your LLM consumption to solve it?
Perfect. Thank you.
Yeah.
Any more questions?
Other questions? All right, let's give him a hand. Great job.
Sure. Oh, yeah.
Good job. Thank you so much. All right, what do we got next? Oh. Oh, yeah, there it is. Advance to the next slide. What is going on? Oh, there it is. Okay. Threat informed defense. What's your name again? Jay. Jay. All right. Let me just put this. Oh, you got it? You already set up? All right. Sounds good.
Good? Project. Okay.
So we're gonna speed, I got my food sitting here, so I'm gonna speed run this one. We're gonna make it here real quick. Well, that being said, this topic is insanely broad. So I could stand up here for probably a month and talk through things and we wouldn't even get through it all. So I went real specific today to something that I have personal experience in both as an engineer and also as an SE. So I'll kind of clarify what that is as we go through, but we'll go ahead and jump in. So as for me, I'm a solutions engineer at Oligo. Like Tim mentioned, before I came here more into the runtime aspect of applications today, I was at Sneak. Prior to that, I was a developer and I got my career started in tech as a tech support at an electronic medical record. Mostly in SQL. So if any of you happen to know much about SQL, this company was primarily rooted in SQL, tons of stored procedures. If you know anything about business logic, stored procedures, kind of messy. So that's where I got my start. Eventually made my way here. I'm married. I have a wife in Missouri with my 3 daughters at the moment that are missing me immensely. So I'm flying back shortly after this. I have a birthday party to go to tomorrow for my company. So busy weekend coming up. So hopefully some of the experience today comes through as we're talking. I'm going to briefly run through most of this. We're going to talk a little bit about supply chain security. I'm not going to educate you all on this. I think everybody in here probably knows at least enough about it as it applies to your job, but I do want to make sure we're all on the same page as far as this goes. We'll briefly cover a little bit of the tools and frameworks, but where I really want to spend time are number 3 and 4 here. We want to talk about the challenges that we face both dealing with vendors as well as the problems we know that they have and why it's so hard to get this kind of information from them because we live a lot of that ourselves. We'll talk a little bit about why runtime visibility is important, and I'll even specify what runtime means in this case. I think you could talk to 10 different vendors and ask them what runtime means, and you'd get a slightly different description from each. So we'll talk about that. And then the end is talking about how this data helps, and then hopefully have some time for questions. So like I mentioned, supply chain security, if you do anything in supply chain security, you know that it is incredibly complex. I actually just ripped a graphic off a website that I thought was kind of in the middle as far as incredibly complex and not enough on there. Like I mentioned, we could stand here for a month and talk through all these things, and this doesn't even touch everything that's out there. But in essence, anything that our code touches that's not ours, that we've inherited, is part of our supply chain, part of that third-party risk. What's difficult here is that we basically inherit the associated risk along with that. And it's also very difficult to model this risk, mainly because there's a lot of security principles that we apply to our own code. And some of these assumptions, namely the defense one that's specific to defense in depth, is broken when we talk supply chain, because we're supposed to know what we're defending. Not what we're defending against, that is important, but what we're defending is something that's a little hazy when we talk third party. So that primary assumption that allows us to defend our own code is broken whenever we talk about third party security. I didn't spend a whole lot of time going through tons of metrics, and I know you all understand the risk associated, but I wanted to call out these 2 that I think really highlight the pain or the problems associated with third party. This is from, the one on the left is from the Verizon data breach report from 2025. The number the year prior for third party being the breaches that involved a third party was 15%, so it doubled year over year. I want to say this is closer to 40, maybe 50% this year, but obviously we're still kind of in the middle of where we're at. Along with this, the 267 days, I actually had to look this number up in a few different places. And while it did, there was some plus or minus there, it was relatively similar. 9 months from the actual exposure until, all the way through to the disclosure, fixing things, the after action report. 9 months it took a lot of these third party breaches or exposures to actually be resolved in the long run. So we've got a third or probably more than that today of all these exposures across things that we don't manage ourselves. And then it takes 9 months to work through all this stuff, which is absolutely insane to me. The cost associated with that alone is ridiculous. So what do we do to manage this? Well, we try to create sort of a shared language. We create a bunch of tools and standards that eventually are actually rather, I kind of have this out of order. We create standards that turn into frameworks, and then eventually tools pop up to support all those. Lots and lots of stuff that exists out there, but the idea is we need to be able to talk to Baxter in a language that he understands. So there's all these things out there. Again, I'm not trying to educate anybody on this today. I don't have enough time to actually get through all this information. But the most common we talk about is the SBOM. We want to know what components are in these applications that you're sending me, or the code or API, whatever we're touching from your platforms. We want to know what's in there.
Then we have platforms that are supposed to ingest that information, help us prioritize. And then there's obviously the attestations and the frameworks, lots and lots of things out there that basically we're saying, here are the standards that you need to live up to. Tell me how you're living up to these standards. So again, just very general there. We're not going to dive into each of those specifically. But the problem we have, and I'm sure this slide is very short for a lot of you because I know the problems associated with managing third-party risk is I could probably have just a slide deck of nothing but those problems. But I think these three are those that I hear most often. And the one that I hear the most is that number one up there, the accurate and timely SBOM, which is really crazy when you think about it, because I'm trying to model risk and I have to question whether or not the information I have is even accurate. And on top of that, the ability to get it, Eric and I actually worked with a company recently where somebody was telling us he felt like he had to go enlist SEAL Team 6 to break down a door to get an SBOM on time from a vendor, which was insane to me to hear. It's like I'm hosting this application in my own environment. I'm assuming the risk, and I have to ask over and over and over again to get that information. So the accuracy and the timeliness of that kind of information is pretty important. Blind spots, I mean, obviously not having an accurate SBOM is a blind spot, but the expertise within companies to both do things like debug and look at these applications or other things that we're hosting or using can be kind of difficult, especially if we don't have engineers that understand the language or whatever technology is in use of these things here. So there's a lot of different reasons that managing third-party risk is difficult, but understanding the applications or other pieces that we're using from vendors is tough there. And lastly, even though this kind of ties into the first two, vendor communication, we're kind of on their time schedule for the most part. When it comes to a problem, if there is some sort of exposure or breach or whatever it may be, we've got to wait for them to bring that information to us. And then on top of that, we have to hope that the information they bring us is actually what we need in the long run here. Is it actually going to help me mitigate the risk in my environment? Which is sometimes the case. I guess it depends on who you're working with here. What's kind of cool though, and not cool, but maybe it is that we understand why this is a problem. Everybody, whether, we're shifting gears from third party to first party for just a slide here, we all experience these kinds of problems in our daily jobs here when it comes to security. So we already understand why vendors have a hard time supplying this kind of information. The timing of data is really interesting, especially in today's day and age. I'll talk briefly to AI in the next slide, but the thought of being able to generate an SBOM, and if you're working at a company that pushes to production continuously throughout the day, the information you have from an hour ago may no longer reflect the application that's being hosted there. Volume of data, I mean, that's probably, maybe that should have been number one. The amount of information from tooling is nuts. It doesn't matter whether it's pre-production, production monitoring, everything in between. Trying to sift through information is insane. You could have thousands, hundreds of thousands. I've seen companies with millions of different alerts across different tooling, and it's wild to try to sift through all that information. What's really hard about that, though, number three here, is that, or what makes it really hard is that there's missing context. I have an idea of what's happening or what should happen with my code when we talk pre-production scans. I have an idea of what happened with my code when I talk runtime monitoring, but oftentimes I don't know exactly what's happening when it's running. I don't know what my code is doing in real time. So I know what's supposed to happen, what happened, but what's happening now is a difficult question to answer. It's almost like if you had a house, oftentimes we've kind of got our ear to the front door. We can hear things inside. Maybe we can peek in the window and see the furniture, whether a stove is on, but I'm not in the house. I'm not in there seeing what's going on. And what that leads to is this final piece here, which honestly I think is probably the biggest challenge of all of these, is that we often chase symptoms and not causes. We're looking for the smoke from a fire. We're looking for problems that exist, and then we have to attempt to try to trace those back to the root cause. It actually worked. And before I get into that story, what this often means is that we're looking at benign information. It's not actually a problem. It's just benign information. We have to try to figure out whether it's a real risk or not. I worked with a gentleman recently who told me we got on a call, and he told me he spent his morning working through a data exfiltration issue, which I thought was really interesting that he was on a call with me if there's data exfiltration happening at this company that would not be something you'd want at any company, let alone this one. And he said, well, it actually turned out it was a backup job that was just taking longer than it should have. So he spent his entire morning sifting through, effectively these first three problems, only to find out he had wasted his time. And now they have to tune the tool, make sure you don't see that again. So it's an iterative process. Maybe AI helps here, but in the end, it also makes it worse. this slide is way too dramatic for my taste, but my marketing guy told me I had to use it, so here it is. But it does paint the picture pretty well. The piece up here at the top, it almost felt to me for a long time like it was really far away. And what that's really describing is a dynamic code base in environments. We're talking business logic that is both written and executed in real time. So what does that mean today? It means that there's ephemeral code that exists that has no documentation. There's no assessment of risk before it's both written and executed. And so we're looking at environments now that no longer mirror snapshots. You can take a snapshot pre-production and then it not represent what you've got there, 10, 20, 30 minutes later. I understand this isn't something that every company is in today. Most of the AI that I see is with developers and other people. We don't see it in as many production environments yet, but there are already companies I'm working with today that have this dynamic code execution, this ephemeral code in their production environments. It's both incredible and scary. Incredible because you can see the human in the loop, I'm sure you all have heard that phrase a million times just in the last month, slowly being removed at a lot of points to where we're, in the future, we get to this point to where it's effectively this dark shop where it's one person managing a fleet of agents where input happens and then output occurs. Every check in between has happened. And that's basically their job as an engineer now. So this just adds an additional amount of complexity. It takes the problems we've already got about not being able to represent risk well and just makes it that much harder. So what do we do? How do I take the tooling now that already doesn't keep up with what we've got? And how do I bring it to the present to not only solve the problems we've got now, but also look at how do I manage AI? Well, this slide, which looks a little busy, but I'll explain it here. It's just going to help me kind of illustrate some technology that exists out there today on the kernel of these host machines where our applications live that we can use to solve this problem. So the slide here is just meant to represent a host or a server, if you will. The top there where you see application, that little purple, it's a little hard to see, but above the syscall API and kernel, that's just meant to be your application. Users interact, different things happen, functions run, whatever has to be done there. Eventually a function says, well, I need to go talk to the host machine in order to get something. Maybe I need to get it from the file system, send a network call. So it talks to the syscall API, which talks to the kernel. The syscall API is just sort of the intermediary between user space and the host itself, kernel space. So this is just normal stuff that happens on your applications, whether you built it, whether you bought it, if you're hosting it, this is the type of activity that occurs there. The problem that we have when we're looking at this today is that the ability to understand what's making this network call or what's accessing our file system is really difficult in real time. We can see after the fact. We can go and look after, but we can't see it happening right then. Turns out there's some technology that's built into the kernel. You can see that little B over there on the left. It's called eBPF. I'm sure many of you are familiar with that. If you've used Wireshark, you've used BPF at some point. eBPF is extended Berkeley packet filter. So you can think of it as just that. It's just an extended and updated version. In the last 3 or 5 years, it has been really, really expanded. So it requires very little permission. It's effectively this technology that allows you to listen at the kernel for any kind of event that you want in a very small scope. So if you're familiar with kernel modules, there's been a couple of companies in recent years that have caused some problems with those. The scope is massive, and the potential impact for those host machines is equally massive. eBPF lives in a sandbox space, kind of adjacent to the kernel, lots of checks already built in. So in essence, it's optimized for the kernel and sort of is created in a very, I'd call it just a very small scope in terms of what it's actually able to accomplish there. So what we can do, and why this slide is up here, is we can take that information at the kernel. We can see all of these events that come through. It doesn't matter what it is. We want to look, in this case, specifically for security-related events, so we can filter through those. And then what we can do with this information is we can actually stitch it back to all of those components that exist in user space. So those applications that I'm licensing or paying for that I'm now hosting, not only can I see all of the different components that exist in there, all of the code, I can actually see what exactly that code is doing. So hopefully that's clear enough. We can talk a little bit more about this, but I don't want to spend too much time on the tech piece. In essence, what I've got here is the ability to see real-time execution of functions and the corresponding syscalls on my host is what I'm able to see here. Maybe that makes sense to some of you, maybe it doesn't. Maybe some of you are already like, holy shit, there's all sorts of stuff I could do with this. And there's a lot of really cool things that you can do. And I think first and foremost, you can generate your own SBOM from this. If it is in your environment, if it's touching your code, you no longer have to ask for anything. It's just something that you're able to generate yourself because you've got the information from the kernel to say, I know these components are doing things, and you also have the user space detail. Vex is something that I actually wasn't familiar with until about a year and a half ago when I started at Oligo. Stands for Vulnerability Exploitability Exchange, which is a mouthful, but it's basically if SBOM is your list of components vulnerabilities, Vex is the context around whether or not those are actually exploitable. So is this vulnerable? You know, I often hear reachability and all these other things that are out there. You'll see that for vulnerabilities. There's a lot of educated guesswork as far as, do we think this component is in use? And if this component is in use, is the vulnerable part of a component in use? Vex is proof as to whether or not that is or is not in use. And the final one here that I actually think is most interesting is that we can look at the behavior of these applications. So not only can we see what vulnerable parts are in use, but we can actually verify whether or not they're behaving like the vendors told me they would. There's a kind of an interesting story here where one of the companies I was working with recently, who's very forward on AI, they've got AI all over their production environment. It's really incredible. They have an application that they've purchased, they host it. When it made its way to production, it tried to send a ping of telemetry data outside of their environment. Now, it got stopped because of the controls they have in place. But what they found out is that this application had a small LLM embedded in it that they didn't know about. The sales team that gave them the application apparently didn't know about it either. And so they caught it, luckily, because of their own work here. But the idea is, if you didn't catch it, you would actually be able to see the functions and what they're doing in real time, saying like, wait a minute, there's some things happening in this application that I was not expecting here. So the idea at the bottom, by the way, in case it wasn't obvious, I have Claude help me lay out my data on slides because the last thing is for me to make the slides up here. So my words, Claude's layout for what that's worth. It does a great job with this stuff. So observed, not inferred is one of my favorite phrases here because there's a lot of the guesswork that I mentioned, the ear to the door. What you've got instead with eBPF and with that user space information is you're in the house. So you see everything that's there. If there's a couch on the ceiling or the stove is on, you can actually see all of that happening in real time. The coolest part though, this is my favorite part anyway, we have the ability to monitor, we have the ability to verify. I think the coolest part though is the containment. So this is the part that's the hardest, whether it's first party or third party, but in particular third party applications, is that we don't know exactly what we're supposed to stop. And oftentimes we stop everything as a result. First party as well, but especially in third party. What's really cool here is that because I can see the function and because I can see the corresponding syscall, there's another technology built into the kernel called LSM, the Linux Security Module, that allows me to tell the kernel, hey kernel, if you see this syscall from this function from a certain component of a certain application, don't do anything with it. So you all are familiar with log4j. I'm sure everybody is in here. It's a dated example, but I use it because everybody gets it. Log4j was just the lucky recipient of an exploit to eventually get to JNDI, right? JNDI is the framework there that was exploited to cause all those problems. But the idea is there was a function in log4j, it's a lookup function that wasn't supposed to do anything other than run a couple of, well, anyway, it wasn't supposed to make a syscall is what it wasn't supposed to do, but it eventually did. It made this syscall down to the kernel to fork a process and execute code. That's not something that a logging library should ever do, let alone the function from the logging library. So what you can do with LSM using eBPF to monitor is say LSM dump all of those fork syscalls from this function, but don't do anything else with the component itself, which means if that lookup function, let's say it did need to make another syscall to the file system or wherever it needed to go, that would continue to function. So the library continues to function, the application continues to function. There is no downtime in terms of the component itself. We just can stop the bad behavior using the technology that's already built into the kernel. So this stuff's just available on those machines themselves. And even cooler is that you don't need a CVE. If you know bad behavior is occurring, I don't need a disclosure to tell me that. If I see a function doing something it shouldn't, if I write my own rules, or if I know the rules, generally speaking, when it comes to libraries or languages, I can actually catch that before it's 6 months down the line and we've been taken advantage of for that amount of time. Last little bit is what do you do with that data? Well, we talked about all the tools. I basically just popped them out into boxes and basically said, you can take this data point, you take those data points from the eBPF monitoring linked with the user space information, and it actually goes into every single one of the frameworks and tools that we use today. So when we talk about third-party risk management, what actually matters when we're looking at those third-party applications? We want to take the scope of information from just this massive thousands or hundreds of thousands of issues down to what's actually running and being executed in my environment. And obviously the frameworks, attestations, SBOMs, all those things, we can augment SBOMs to say, well, here's your list of information, but now we can tell you what's actually exploitable within that list of information. And that's it.
I had a question. What operating systems, does it work with Windows?
So I was going to bring it up in the presentation. I figured it'd be the first question. It does not. Windows doesn't have eBPF
Right.
yet. I think anyone you talk to that uses eBPF, whether it is for security purposes or whatever it might be, Windows there's a lot of people knocking on their door to get that in there. But once they have eBPF, there is a version of it out there, but there's a lot of unsigned DLLs in there, which nobody's willing to use. So we just have to wait for them to get this out there. Linux for now is what needs eBPF or what has eBPF.
One question. Have
Yeah.
you seen code created by AI agents that are making those type of calls, syscalls that are not expected?
So is the question whether or not you would see an AI agent making the functions making the syscalls? I'm not sure exactly.
So the question is, you said that when you had the presentation about the ephemeral code that is being created
Yeah,
with agentic AI,
I see.
that code is not being reviewed, right? Most of it.
Correct. Yeah.
So have you seen cases where AI just generates code to do something, but in addition to that, making syscalls or API calls to the kernel that were not expected?
I see. Yeah. So there maybe one thing to clarify is that a lot of this ephemeral code, the dynamic code, is reviewed in some capacity. It's often not just created and executed willy-nilly. There are some in these harnesses they use to execute these things. There are immediate review processes that look at and evaluate a lot of this code. So there is some of that exists. Generally speaking, I would say no is the answer. You don't see a lot of deviation from what should happen. What's really important when you're looking at the kernel is understanding how languages are meant to operate. That's why I say we don't need, that part I had over here where you didn't need a CVE. If you understand how the languages are meant to interact with the host themselves, so if you can in essence reverse engineer Java, for instance, you know that in JNDI, the framework, it's maybe not supposed to, a certain method is not supposed to access the kernel. AI uses the same languages, the same frameworks. AI under the hood for the most part is Python or whatever else it might be in some environments. So if it misbehaves, you would pick that up just like you would for third-party code, first-party code. It really doesn't make a difference.
Thank you.
Yeah.
You mentioned syscalls. Is there any sort of hook into something like a denial of service issue, like a regex based, when it doesn't quite hit a syscall or the kernel, but
So-
it's with an application?
Yeah, no, it's a good question. There are ways to go back to where you only live in the app layer itself, right? There are things that happen outside of the kernel, right? There's even, there's a lot of edge cases as well. There are certain ways to do that. Even looking at network traffic could be a big one. You can use eBPF to do that without having to necessarily see a syscall be made. But specifically to something like denial of service, I would say this is not the tool for that. There's a lot of things in general when we're talking about exploits or other, anything around exploitative behavior. In most cases, at some point throughout that entire attack chain, some sort of a syscall is going to be made. It's difficult to say when in the attack chain that's going to occur, but for most of them that will occur. Obviously, there's outliers as well, Tim, but yeah. No, but for denial of service, I would say maybe this is probably not the tool for that.
It's so far it sounds like this can be implemented on the OS itself, but in regards to containerization, can this be applied to that same environment? to
Yeah.
a containerized environment.
Absolutely. As a matter of fact, I think this excels in containerized environments. I think that's where this does its best work. I would say if you're talking Linux, which is what we have to for eBPF's sake, whether it's bare metal, whether it's a VM, whether it's Kubernetes, the actual functionality is similar across all of those. Now you can strip functionality out, and occasionally I've run into people that have removed some of this functionality, but for the most part, as long as you're on kernel version 4.18 and above, you've got all these things available. Containerized environments, what's really great here is looking at the kernel means that you're not hooking into each individual container. So I have an awareness of the containers, I have an awareness of the components of application in those containers, but I don't have to have, let's say, like an agent for every single container, right? It's not a sidecar, there's no sort of code modification involved there. I just listen at the kernel of the host. I could have 100 applications, 100 containers on that host. And as long as I'm listening at the kernel, I can map those back to their individual components. Yeah. Any other questions? Cool. Okay.
All right. So my name is Eric Peterson. I'm a solutions engineer at Black Duck. I've about 15 plus years in AppSec. I was a practitioner for the bulk of my time. Kind of switched to the dark side, the solutions engineering, fairly recent. So part of my time was at MITRE working with the CVE and the CWE people. So certainly have a lot of knowledge about those areas. So first, I want to kind of talk about AI and how it's affecting, but I want to go into like mythos and kind of talk about specific attacks that kind of derive from there. Certainly, AI it's not really inventing new attacks. It's kind of making the old ones a lot easier to do. So we're seeing huge skews in just AI embedded attacks. Phishing is a huge thing. Back in the day, you could tell a phishing email because they spelled half the words wrong. Unfortunately, AI doesn't generally spell words wrong, so it got a little harder. But the biggest problem isn't about like AI 0 days. It's about generative AI making the attacks or generating the attacks faster than ever. So, this is kind of the bulk of what we've seen so far, and I'm sure this is going to change every 5 seconds for the next, year. But, the primary areas have been in phishing content, but then payload and scripting areas as well. A lot of people are talking about fully autonomous attacks, but they haven't been the bulk of what we've seen yet. I personally think that that's going to change. Generally, it's in payload scripting and then phishing areas. So how does all this kind of affect AppSec? So there's 2 big areas. I'm sure you guys have all seen it, but the just forgot the name of this. The me time, the 0 day clock. The 0 day clock. This has been trending since before, since before AI was big. But what we've seen is a historical downward trend in times to create exploit. Significant down. I think last year it was around 10 hours, and they're projecting within an hour this year, and then next year they're saying within minutes. So exploits coming out, or CVEs being identified, or even pre-CVEs, and then exploits getting generated in minutes to hours after that. So I think historically we've been flooded. I think we're going to get even more flooded. There's going to be more critical zone vulnerabilities, and then vulnerabilities kind of off those vulnerabilities. So there's this research paper that was released, I think it was like March. It was sponsored by, I think it was like 100 CISOs put it together. Everyone should read that. If you haven't, you probably already have, but it's an awesome research paper. It's all about, and it's not specific about Mythos, it's about any of these AI platforms, because there's tons of them out there, but their ability to find exploits and then exploit them change completely how you as a responder have to respond. It gives, it disproportionately benefits essentially the attackers, because vulnerability disclosures come out, you could probably create an exploit within a few minutes after that with tools like this. So let's talk a little bit about building a Mythos-ready AppSec program. So there's kind of 3 pillars. There's a lot of pillars in that research document. I'm just kind of pulling out 3. First one is coverage. I think in my time as an AppSec engineer, I was more concerned about the Rust payloads, because everybody was switching to it, but nobody scanned it and nobody was scanning it all. So you have all this stuff on your attack surface that either you can't scan or the engineering team has been kind of, yeah, we'll get to that maybe next quarter. You know, so you're not scanning any of your attack surface because the teams are just kind of pushing back on you. Once you do assure, or once you do identify attack, it's all about how quickly can you respond. That's the big part of that research paper. It's not about finding the exploit. It's like when you find the exploit, how quick can you patch it? Because there's exploits that are already being generated. And then one of the big parts of that paper is adding agentic AI workflows into your response plans as well. So imperative one, ensuring gap. When I worked with an AppSec engineer, the CISO prioritized us to cover our attack surface, model our attack surface, and then find out what we're missing in our attack surface. And then how can we gain additional coverage? What we continually found is that teams weren't adopting the tools, or they were too busy working on other projects that they hadn't adopted our tools. And so we just had gaps in the attack surface, which CISO could go kick some doors in if he had to, but we had to tell him what doors to kick in. So one of the biggest things is ensuring your attack surface is covered, but then applying policy consistently. I think historically, rolling out tools, you'd have to integrate with the CI/CD, you'd have to integrate in every single code repository. Building or having a system where you can hit buttons and onboard and employ your policy to your entire organization is something that you need, so that you don't have to worry about what you're missing, because every time a new repo comes out, you can automatically onboard it. And then continuously scan those changes, not wait for the security team to hit the button, continuously scan it. Kind of almost without their permission, you're just scanning it. Once you get that data, you need to prioritize the data. I think we've all looked at CVE reports and seen the 1,000 of CVEs and said, oh my God, where do I start? Well, you have to start with reachability. Reachability, if you don't have it, you have to get it. The vendor has to tell you, I've found a vulnerability. Here's the proof that it's exploitable or it sits in the control flow. If they can't do that, you shouldn't be prioritizing, or you should know. Second one is the exploitability. The EPSS scoring is all about the percent chance that vulnerability could be or could be exploited. So it's a whole ranking system based on research that they do on the vulnerabilities to see how likely they are to be exploited. It's something that's rolling out a lot, and it needs to be integrated into there, because it's going to help you understand, should I? Like reachability says it, but how often does this even get exploited? Or is it extremely exploited right now, like everybody's hitting it? So once you've found the vulnerabilities, identifying ways to automatically fix or help your developers to either, no, I'm not saying AI just fixes it and nobody knows, like that's never going to work, but proposing a fix and having your engineers approve or deny it, or look into it. But again, finding a vulnerability and helping them find the fix faster than you've ever done before. So the second one is all about supply chain. So, back in the day, like 6 months ago, a bug would be introduced into code. So there would be some time period, the 0 day. Eventually it gets discovers, and then at some point after that, an exploit becomes publicly available. Generally, there's a time period between the two events. Then during the entire time that exploit becomes available, you're concerned about patching it. Hackers can start analyzing and searching your code bit or searching the internet to see if they can find who's exploitable. And hopefully you fix it before somebody finds that you're vulnerable. Now, with Mythos, exploits can be completely generated before the public disclosure even occurs. So a major CVE can come out, the engineers or whoever is affected are trying to remediate it. Somebody gets the hint, sees the pre-CVE, generates an exploit before the public disclosure has ever even happened. So you have to respond even faster, or maybe even faster than you even find out, which obviously is impossible. So it actually got a little bit worse. I think it was April 14th, NIST has historically been falling behind. Last year, they were 45 days behind in generating reports the CVSS scoring matrix for the vulnerabilities. They were falling behind. This paper that I mentioned earlier actually predicted that they're going to continue to fall behind and eventually be too far behind. Like 4 days after that, NIST said, we're not even going to try anymore. We're only updating what is on the KEV and what is on the known federal software list. So prior to that, it was taking 2+ weeks for CVEs to be enriched, so the data was falling behind. And with this system where things are getting exploited faster, your data source has to be very accurate. The other big issues is historically the CNAs that do the rankings for them have been very biased. They've been very overly aggressive on the rankings, and then NIST would come in and update them and be like, no, you want to load too hard here. It's not that exploitable. So, obviously the CVE flood is just going to further, generate additional issues here. So you need a system that can analyze 20,000+ sources looking for vulnerabilities, backing those, or when the CNAs are generating, back up the system, but primarily continuously monitoring and looking for known exploits that come out for those vulnerabilities. Once a public exploit hits on the open source repositories, you're in danger if it's reachable and if it's external. You also need to create a whole new prioritization mechanism. So from the bottom up, you need to be making sure your data is accurate and your data is coming in correct. It's not 45 days late. But once you get it, ensuring that the underlying tool has proven to you that it is reachable, it is exploitable in your environment, then running the CVSS scoring mechanisms on top of that to see how dangerous, or generally the rankings of these vulnerabilities. Then the KEV, if it's showing up on the KEV, that says it's actively being exploited in the real world as we speak. And then this EPSS scoring on top, as well as telling you the percent chances. So there's another whole factor here is we have this whole Hugging Face AI repository. It has a lot of great open source AI models. Well, people are uploading malicious ones onto there as well. So you almost have to be, your SBOM kind of has to include what AI tools you're using in the first place. Because if you're using an AI that has known or has been trained to do bad things, you need to audit that and you need to keep up to date with it. So the third transition, or the third imperative, is integrating agentic AI into your secure software development center. Again, that's going to help you go faster. So AI is not just a tool. Well, it's a little bit more than that. So it adds additional thinking capabilities. So historically, when we look at static application security testing, the really good ones are rule-based, meaning they define what SQL injection looks like. They define what cross-site scripting looks like. They then look for external sources where data flows in, track it across that application into that weakness. And then it's telling you, not only did I find a weakness, but I found a flow to trigger it externally. The issue with that is you can't define rules for every single CWD class, specifically like business logic vulnerabilities, IDORs. You can't define rules for theirs because you need to understand the purpose of the application. That's where agentic AI comes in. It can understand the purpose or the intent of your application. Pairing that with additional, like your traditional SaaS, you can say data flow is occurring, data is flowing from an external source into this area, and now you start finding IDORs. IDORs are very common because no tool really finds them very well. No tools even really check for them. That's why they're so prevalent. So, meant to modify the slide a little bit, but so what you need is a tool that kind of takes agentic AI and builds it into the areas that it's very critical in. You need something to do intelligent triage. It's one thing to find a vulnerability. It's another thing to intelligently look at it and give a scoring as to whether it's a false positive or true positive. And giving you a score back that says, I think 82%, I'm pretty sure this is, and then filtering policy off of that. And then based on that intelligence, then doing a code fix and saying, how confident are you, AI, that you actually fix this? Give me a score. Okay, I'm 52% sure this is going to fix it. Okay, I'm just going to get rid of that. I'm not giving that to my engineering. But then the supply chain attacks are only going to continue or more. Apparently, these open source guys fall for phishing campaigns just as much as everyone else. And then all of a sudden, you have a malicious dependency out there. And then agentic AI pen testing, that's a big thing. Everybody's doing that. but also dynamic threat modeling is kind of the first one I started with. You need to understand your attack surface. You also need to understand how these software code bases that are coming out into the world are touching your attack surface. Because that's going to prioritize when a vulnerability comes in at CVE, their first question is, okay, is this externally accessible? Reachability is one thing, but through your threat modeling and then updating your threat modeling automatically as things continually change to make sure it's accurate. That's the hardest thing about threat modeling is once you've done it, maybe a year goes by and everyone's too busy for it, and then it's out of date, right? And oops. So keeping those up to date. So AI is not a silver bullet. You know, that's there's no one tool that's going to save you. The biggest issue with some of these Anthropic bugs that they found is they had highly trained vulnerability experts, and they had pretty much $20,000 to do a single scan. That's not going to scale. You're not going to run a scan every day for $20,000. I wish we could, but AI needs to be a layer on top of the layers that you already have. It needs to be a complement to the existing tools that you have and provide additional logic or intelligence on top of what you're already doing. It's also important to know, I keep saying Mythos. Mythos is just one of those tools. There's tons of, and there's going to be even more, and there's going to be ones that are controlled externally or by, you know, foreign nation states that are designed to come after these issues. Mythos is just it's a buzzword. Yeah, it's an example. So again, AI complements, but it doesn't replace existing AST. You know, traditional AST, it needs to give you the coverage, but again, you need to focus on repeatability, false positive, context windows, all these additional things, and then have your LLM supplement that. So yeah, some key takeaways. Yeah. So yeah, just to summarize, you know, as security engineers, as the security engineers in this room, your biggest concern is finding the vulnerabilities that your underlying tool can prove to you are the most dangerous to your organization, and finding ways to automate that as fast as possible so that you're continually up to date is kind of your biggest advantage of the AI. So I think that is everything that I had.
Yeah, question back on dynamic threat modeling.
Yeah.
So I know some of the models are implementing threat modeling skills now.
Yep.
Making those available. Do you have any recommendations around that?
Yeah, I mean, skills, I'm not a huge component of skills. You've seen so many prompt engineerings go into that. So obviously the first thing is where you're getting the skill from. And, you know, I'm more scared of where the skills are coming from. Certainly skills can really help here, but I think the underlying AI in its context, the context that it's given. So I think a skill could do a pretty good job, but I still think you need examples of what open source vulnerabilities or open source issues have looked like. And you need to provide that as context or examples to supplement the threat modeling. Because threat modeling is drawing a map of how data flows, but then B, taking your giant list of exploits and then drawing them as threats across that map.
Yeah, one of the things I see is you have the conventional tools out there for threat modeling, threat modeler, you know, there's a lot of different ones, and they're incorporating some AI themselves now, of course.
Yeah.
But the issue with those is there's only so much you can do to customize those to understand your context, as you said.
Yeah.
Whereas if you take an AI model and AI tools and you engineer your own threat modeling to fit your exact CI/CD pipeline, and have the touch points along the way and bring in the standards, bring in the policies, bring in the context along the way, and make that so as those change, your context changes. I think that would be a lot more useful. The question is how much is that going to take to develop, right?
Right. Yeah. I mean, that's certainly, the first process is just modeling your application and keeping it accurate. And that's something AIs can assist with. The second is routinely and accurately applying threats across that tree and all the various different threats that could come out, you know, tomorrow or the next day, additional attacks to it. So I think the primary point here is mapping and drawing that attack surface and then updating the priority list inside a platform so that when a threat, a CVE comes in, a high score CVE, you see, okay, what are the most critical applications? And again, what are the threats on that? Or where is it on the attack surface?
Yeah, one of the issues with CVEs is, and what we do for our AppSec program is we take those and we reevaluate those based on our risk appetite and
Yeah.
our context, right?
Right.
You know, what
Exactly.
compensating controls do we have in place,
Right.
all the, and so many of the criticals or highs that we get end up being lowered to mediums and so
Right.
forth, right?
Exactly.
Whereas if you go with the conventional tools and what's coming out of the box, you would have a lot more highs and criticals
Yeah.
because it doesn't take that context into account.
Exactly.
So we can leverage AI
Yeah.
to help with that triage and do it a lot quicker
Yep.
to meet the mythos type of
Yeah.
threat, right?
Exactly. So yeah, I mean, that's a great point. You know, the tools, a lot of the tools can say this is critical, but then it's only if you're exposing or using a certain capability. And even then it's like and I'm talking about a CVE, like if you do it in a certain way, it's very vulnerable. Question is, do you do it in that way? And that's a large task for you, your engineers and your developers, or sorry, your security analysts or your AppSec team and your developers to kind of go through and see, are we actually doing this in a way that's exploitable? Prior to reachability, that was an even bigger problem because you didn't even know if you even called the expose function. It was very difficult or time consuming to figure that out. So certainly reducing that time and then reducing the initial research so that human in the loop, when the human comes in, there's a lot more data and they're just reviewing that data and saying, oh yeah, I think this might be, or no, I don't think this is an issue.
They can move more quickly.
Right,
Yeah.
exactly.
Who we got?
Thank you. Regarding the cost that you had mentioned, where it's not economical to run it in the way that they're doing it.
Yeah.
Do you foresee as time goes on, a Moore's law type curve where it starts getting better and cheaper over time?
I mean, in my opinion, I think that's a compute question because they spend so much time training these darn things and the giant data centers they build that I think they're offsetting costs. I certainly agree that there will come a time where compute or maybe, you know, operational is at profit and costs will come down. I certainly see that as a possibility in some point in the future. But I still think that scanning early and scanning quickly is a bigger priority and finding these issues. And as they're continually being identified, agentic AI is updating rule sets so that you run very fast in the SDLC. And agentic AI to find that could take, I don't even know what the time requirements are for it. So even if it's cheaper, there's still a huge time requirement. I tend to think of them more like major pen tests. Like you do a quarterly pen test where, you know, once a quarter, you bring in your agentic AI tool and you do an entire analysis of your code base and then triage and go through those issues. So.
Hey, thanks for the talk.
Yeah.
Have you found any tools or frameworks that are really good at bringing in that context outside of the individual application? So like application to application or even infrastructure level, something that can tie all the pieces of like, hey, this is behind a WAF, this is behind a firewall, and then give you that exploitability, reachability, and vulnerability.
That's a good point because we see that a lot. You know, you do these, you know, analysis on these servers, and then it comes back, you get all these, you know, SSL issues, only to find out that you're sitting behind a WAF. Like, it's a difficult problem because it depends where you're analyzing, right? Like, to truly, for a tool to figure that out, it kind of has to see runtime and say, okay, you're sitting behind a WAF. Whereas many of these tools they're sitting inside the server environment or they're sitting inside inside SDLC or SCM, and they're just running their analysis there. So it's too far from context. So I think many of them, I think AI could maybe figure it out, but again, what's the false positive rate and what's the hallucination rate? Because it's going to look for like a YAML file that says I'm a WAF configuration. It's like, okay, well, they must have a WAF. But in reality, maybe they forgot to delete that file. That the file's just sitting in SCM and it hasn't been used because they it's too hard to figure out. Like you need a runtime tool to look at runtime to really figure that out correctly. So I think tools can do that. I think you could probably say, okay, we found a bunch of SSL issues. Now go hit the target from a dynamic analysis perspective, and then triage those out. because when we saw it in a dynamic position, it wasn't there. I think they can figure that out in some context.
Thank you.
Other questions?
Thank you for the presentation. It's great. One question. Besides all the suggestions that you put in the deck, are there any structural or architectural changes that companies can make to reduce the risk?
Oh, well, yeah. I mean, the whole point, one of the bigger points of threat modeling is if you threat model earlier in the software development life cycle, you're going to catch things earlier. The issue is, from my experience, when you knock on a engineer's door who's trying to prototype something, they don't want to talk to security. And they're like, we'll figure it out later. It's like, that's the wrong answer. And then you don't get, from my perspective, they're like, well, let's just let them figure it out. So the earlier the security team can be in the software development lifecycle, the better chance you have to inflict, benefits to the organization. It's just getting into those conversations and being able to actually inflict change. It is more of like an organizational thing.
Thanks.
Good? All right, excellent job. All right, before we get into the next presentation, can we do another raffle? My magic glasses here. We got an Android tablet here. Yeah, I know. Super. Yeah. 471-3409. Did they leave? Is that me? All right, let's do another one. This one feels good. Let's see. All right, 471-340. What's the tension? 4. All right, look at that. All right. Okay, great. And with that, where's the controller? Oh, thank you. So I'd like to call up our next presentation, supply chain threat we're not ready for. All right. All right. And so push the middle one to advance. And other than that, you're good.
All right.
All right. Sounds good.
All right. So hello, everyone. Thanks for having me here today. Happy Friday. My name is Dima Garbanos, and the issue I wanted to discuss with you today is probably one of the major challenges, I would say, in the last decade in the security area, the software supply chain. I'm more than sure that you guys heard about that term before. And the reason I chose the topic for that particular slide, the supply chain threat we're not ready for, is because most of the organizations have security tools, they have security teams, they have security programs, and yet the attacking surface keeps growing way faster as opposed to the way we're able to deal with it. So let's dive into it and see why. So traditionally, I would say that the security team tends to think about a pipeline as a pretty straight line forward process. The developer gets to develop a code. The code is built, deployed into production. And the risk is pretty linear in this case. With that being said, it's definitely not the case anymore for the modern applications. We have the open source, of course, but then we have the containers, we have the CI/CD build, we have AI generated code, we have a model, third-party APIs, runtime, etc. The point I'm trying to make is that the modern application, it's not a pipeline anymore, it's an ecosystem. An ecosystem behaves differently than an application. It doesn't necessarily introduce the risk of within an individual components anymore, but the risk in many occasions lies in the interaction between these components. Attackers, they definitely get it. Defenders, I don't think we're there. So let's see why. Let me focus on three main aspects to elaborate why our current defense doesn't work. So the first one is obviously the scale, right? I think we all will agree that the scale, the usage of the open source components have exploded. And with the AI generated code, we move even more faster. And the amount of code that is consumed or generated today by the organization is more than ever. Another one, obviously, is visibility. We had shadow IT, and now we also have shadow AI. We have some runtime dependencies, which static code analysis are unable to detect. And most of the teams are not really aware to the entire set of components that are running within their environment. And then the third aspect, which is most often overlooked, it's the operational one. Most of the organizations have scanning tools. So the issue is not the absence of findings. The findings are definitely there. But in many cases, these findings are treated exactly the same way, which basically generate a lot of alerts. The backlog keeps growing, amount of tickets is growing, and at some point, the teams get buried other remediation efforts, and the security program stop working. They slow down and really get stuck. So let's see where most of the supply chain attacks surface are actually take place. Traditionally, when I will say supply chain, I believe most of the people will think about open source, malicious packages, dependency confusion, typo squatting, and etc. But that's not the case anymore. Now we have CI/CDs and dedicated build systems. We have, of course, the AI, which introduced unsafe models, prompt injections, agents, rat poisoning, and then there are different vendor infrastructures. I think the main challenge today, at least based on what I see with some of the customers, is that they keep treating all these components individually and not necessarily looking into the connection and the interactions of these components. And this is where the attacker actually trying to exploit the connections, and most of the supply attack chains are actually successful. Another common gaps that I did want to cover is definitely the vulnerability prioritization. So if you think about a common organization, just imagine a picture that they have about 10,000 total findings. The reality is that only hundreds of these findings are eventually exploitable, and even less are reachable. So the idea is not necessarily to treat all these findings the same way, and actually prioritize them based on different factors like executability, reachability, EPSS score, runtime context. And that way, you basically can give the attention to these findings that are really matters. AI, another challenge. Most of the companies, again, when it comes to AI, they do have the needed controls in place, but they not necessarily treat AI as a part of the supply chain, which is obviously wrong. It's definitely part of the supply chain. You can think about the model as dependencies. You didn't develop them, you consume them. Prompts are basically executable logics that impact, I go back. Sorry. Prompts are executable logics that impact the outcome and the behavior of certain components. And then agents generate different interactions between system and tools. Route positioning and obviously different tools. And I think the main issue with the AI is that we moved too fast with adopting it, but the security government is not necessarily there yet. And that basically creates different standards like AM bombs, prompt hardening, runtime enforcement, guardrails, and the red teaming. But I'm sure that I will ask, and we actually had a conversation about that earlier in the room, what is the right way to handle AI and the compliance governance, and there are way different opinions about it. Another interesting aspect is 0 days, right? So again, traditionally talking about 0 days, I would say that the process worked the following. A new CV is published. We perform a scan, a ticket is created, the ticket is being triaged, remediated, and basically deployed into production. That cannot work anymore because everything moved with the speed of AI. And we talked about Mythos in our previous presentation. So it doesn't scale up. And I think the way to go about it, and actually will kind of, the top part is the idea to illustrate the previous process versus the modern one, is that that threat intel is detected automatically. Automated exposure analysis happen behind the scenes, reachability, exploitability, and other factors that we can add. Automated remediation. I know there are different opinions about automated remediation, but the reality is that manual automation doesn't scale up. I'm not saying to do automated remediation wherever, but wherever the situation allowed, that's definitely helps the companies to scale up. And then continuous communication. The point I'm trying to make here is that the main shift is not in the detection, it's actually in the speed we are react. Another few challenges is shared ecosystem. And I think that doesn't get enough attention. The ecosystem is shared, but the accountability is not. We do use the same vendors in many occasions, and some vendors inherit open source components, which they are not necessarily controlled. And just to add to that, the regulators are also trying to create additional enforcement in order to comply with their standards. And that's why we see different regulations start coming up, like different acts, executive orders, NIST, and AI government frameworks. And just to make it a bit even more challenging, the critical infrastructure is more than coupled. So on the right, I'm sure that you're all familiar with these major events like Log4Shell that we discussed earlier, where a single dependency created a global remediation effort, SolarWinds, where the pipeline was compromised, Polyfill, that an abandoned asset created a major issue and a surface attack. So as you can see, the attacks are different, the techniques are different, but there is one common ground for all these aspects. we do not have enough maintainers who are really responsible for this code. We are using, in many occasions, shared environment, shared variables, and shared dependencies. So what does work? Continuously discovery, right? Be aware of all your AI components, shadow AI, obviously open source components that you have within your inventory. Contextual prioritization, reachability, explorability, and runtime exposure. Remediation, remediate whatever is possible automatically based on your AI-driven workflows. Behavioral AI security, it's not enough just to secure your models. You also need to harden your prompts, secure your agents, red teaming, guardrails, and then the operational response. This is the key point here. Your operational response essentially becomes a key differentiator because the ability to act fast today, respond fast, is more than crucial than ever. The exploit, as already mentioned earlier, become in some cases available within minutes or less than a day. And I see that many companies still use workflows that not necessarily feel and suit for the current era. And the time it takes them to analyze the impact actually longer than the proof of concept for the exploit. So I think some of the things are kind of obvious already, and we can see the trend of how the future will look like. The AI acceleration is everything. It accelerates the development, but it also accelerates the research and the exploit. Boundaries keep dissolving. There is no such thing anymore like application. It's application, it's infrastructure, it's cloud. It's basically one common attacking surface. Runtime interactions matter more. I would say the context start being even more important than the inventory. And then the speed, as I already mentioned, is the differentiator. And just to make it a bit more realistic and pragmatic, I decided to choose the architecture of NAND, also because I work for NAND. But generally speaking, you can see that on the top level, it's mainly the AI-related components. And then on the bottom, it's the traditional offset, SCA, SAS, and DAS. The key thing or the key point I want to make over here is that all these components are connected together. And the fact that they are connected together, that everything as a single platform, is actually helps you to see that context that I was referring earlier and where the majority of the supply chain attack take place. Other than obviously you have all the prioritization factor that I was talking, continuous detection and auto remediation. And the goal, and this is where we basically shooting with our strategy, with our vision, is to remediate 75% of the findings. I will not tell you that everything is perfect and everything works with no issues, but we're not that far. Zooming out from that architecture, just because I did get some requests prior to that meetings, I know there were many folks interested in Renovate, so I kind of wanted to show where Renovate fits into that entire picture.
All right, we're going to get started on our security panel here. Some good conversations going on if I get everybody's attention. All right, great. Okay, great. So put on my magic glasses here. So our first question, who owns the supply chain security in the organization? Who should own it? You want to go
I don't mind.
right to left or?
I think it's a common effort. I would start by saying that even though the security team maybe account for it, but it's really a team effort. And I think the organizations that I see where they are unable to operate collaboratively about it, they are struggling.
Eric, anything to add?
Yeah, I mean, everybody kind of owns it, right? It's not one department. It kind of has to be everyone, and certainly a legal team has to be involved in license compliance. So I'd say it's top down.
Great.
Yeah, top down for sure. Legal being involved, a lot of the other business owners, especially the people using those individual products or whatever third-party pieces they're using.
Excellent. Second question, what will supply chain security, what will strong supply chain security look like in 3 to 5 years?
Automated.
Yeah.
I don't mind starting out. So
Yeah.
I think if you look at, I think you could compare it to development in a way. I think development is moving to where your individual developer is no longer writing code, but managing a fleet of agents using harnesses, all these things. And so I think this type of security, supply chain security especially, I think what we'll wind up seeing is a lot of security engineers that are more responsible for managing a lot of agents, continually updating harnesses, all these different things to actually handle a lot of the security aspect in 3 to 5 years. With how fast things seem to be moving, 2 years ago, I wouldn't have allowed AI to write me code. Now it does it better than I do. So seems pretty quick.
Yeah, interesting. Anything to add to that?
Yeah, I mean, it needs to respond faster than ever, and it needs to be completely in sync with versionings and backwards compatible as well. So I think it needs to be as automated as it can, just to ensure that, you know, the more hands-on it gets, the more painful it is and the more prone it is to mistake. So
I think it's already partially automated today. Maybe not necessarily all the way with AI, but we do have tools that automate it. And there is, I think the trick is to find the right balance and when it should be automated and when you should do it manually, or for what items it should be automated and for what you should do it manually. And I think that threshold will keep shrink, meaning we'll get closer and closer to 100%. With that being said, I don't believe that we ever will be able to reach 100.
yeah.
We should not, at least in my opinion.
Yeah.
Okay, great. Okay, let's look at this, the rest of this here. Why are suppliers still prime ransomware targets?
I mean, it's the easiest way to get into an organization, right? Like if you find a vendor and you can exploit that vendor anywhere that vendor is in place, it's your attack surface, right? You can attack anywhere that it is exposed. So I think they're also harder to update, like because they have to make the code fix and then the company has to install or deploy the code fix. So I think it's more difficult to get fixes to, or you always run into the environment where it's so old that nobody even knows who's running it anymore. So that's a pretty good target. Like if nobody knows how it runs, it's a prime target, and it's old. It's probably very vulnerable, right? I think the connections are the biggest one. If I get into a single third-party vendor, I could have, like you mentioned, all the connections to all these other things. But I think the sort of the lag time between something happening with a third party and then the notification, the disclosures, all those things to the actual people using it, I mean, it makes it a lot easier to manage rather than trying to get into a larger, more established enterprise organization. I can take a smaller company, get in, and eventually do what I need to do to that enterprise organization.
I will take a slightly different track. I think it scales up. That's the easiest way to get to many organizations at once rather than target them individually.
Oh, that's interesting. So you're saying that, you know, pick a vendor that's being used by multiple organizations.
That was exactly the case with Polyfill that I mentioned earlier. You pick up on some common third-party that you know that commonly used, and if that works, you're probably inside hundreds, thousands of organizations. There is no single chance you will be able to do that manually.
Good, good. Which supply chain risk is most underestimated today? We may have just spoke about.
That was
it, I
my
don't know.
entire presentation. To keep it short, the connections between the components, it's the ecosystem. It's not a specific, it's not AI, it's not third parties. It's really all these connections that the suppliers, the attackers are target, and they are pretty successful in this area.
Eric?
No, I mean, nothing really to add to that. That's a pretty good summation, I think.
Jay?
I think similar, but I think it's more understanding the actual versus expected behavior at those points as well. So being able to monitor those.
Okay, great. So the question was, which risk is most, supply chain risk is most underestimated today?
The one that's least in the news.
The one that's least in the news. Okay, I guess that would be true. How is AI changing supply chain attack sophistication? Well, we kind of talked a lot about that today, but maybe we can talk about some examples and so forth.
You can get dynamic behavior and just the persistent nature of AI that can do asynchronous or unmonitored trial and error, and will just report back to the command and control service as soon as it's made its way in.
Yeah, I think it's just expanded how we can attack these days. You know, prompt injection isn't just about asking a prompt to do something poorly. It's about embedding something deeper within the AI engine in order for that to be targeted later on. So I think it just expands the ability for somebody to gain access.
Great. Eric?
Yeah, I mean, the biggest risk is reducing the time to exploit, or even finding, realizing there's a vulnerability and finding there's an exploit already available for it. Like, and being able to patch or respond in a system where you may already be a target for something that you were just finding out, right? So it's a vulnerability, a 0-day that's found and exploited in minutes, as opposed to days or weeks, right? So.
Yeah, I would agree with that. I think it's really about the speed and how fast everything's moved. And I kind of talked about that a bit. The workflows that are being used today are not necessarily up to date and outdated, and are able to handle these type of scenarios.
What are the biggest barriers to supply chain transparency? It's an interesting question.
I think we kind of faced with that in the past with the shadow IT, and now it comes with shadow AI. It's basically the visibility or the ability to continuously know what's going on in your environment. And obviously, since everything moves way faster, it makes it way more harder.
Yeah, I mean, it comes down to transitive dependencies. But there's also kind of a sea of noise there, right? Like when you're analyzing an SCM system, you're picking up dev dependencies and test dependencies. And I think the tools are pretty good at finding it, but it does depend at what are you running the analysis? Like, is it pre or post build? Are you missing dependencies? So certainly ensuring that your system and your vendor is doing it correctly so that you're getting the transparency into your system. So once you have good visibility, if you don't have good visibility, you don't know that you have good visibility, right? So, and then filtering through the noise of just tests and all that. So, could you repeat the question one more time?
What are the biggest barriers to supply chain transparency?
Right. I think the time spent waiting. I think you mentioned it already. Is trying to get the accurate information, waiting to get the information. But I think as things speed up, we're going to just expect to have that readily available to us at any given time. It's not something we can request anymore. We just have to know that information on hand.
Yeah, because we have to move quickly.
Yeah. Yeah.
That's good. Anything to add?
Maybe around the fuzziness of these supply chain risks. As you said, the AI itself is already a black box by nature, and it's got a lot of fuzziness. You got to build guardrails around it. But at least having the shape of knowing like which one of your SaaS vendors are using AI under the hood and what kind of non-deterministic behaviors can you expect of this particular system. Trying to understand those boundaries, or which of the components, as Jay was mentioning, there's embedded LLMs. These are small enough now that you can run it on a MacBook. You have to understand where it has sufficient compute to run these kinds of non-deterministic systems, and what guardrails or bounds can you enforce around it to limit the.
So AI is bringing more challenges to that transparency.
Yeah,
Right.
I would say so. 100%.
Yeah. Good. Let's see here. I'm going to ask a few more questions, and I'm going to turn it over to the participants to think about your questions. Are SBOMs being used effectively or just as compliance artifacts today?
If your SBOM was sitting in a text file on a server somewhere, I don't think they're probably being used correctly. I think you need a platform that communicates that you can search SBOMs across versions, across multiple code bases. You need a platform. If your SBOM is a JSON file sitting somewhere, I think you're probably not quite using it right. I think an SBOM is still a point in time answer. I think it is still an answer. It's good data to have, but it's still static documentation. And if we talk about things being more dynamic and ephemeral, we need something that actually tracks that dynamic nature of code bases. So understanding what's supposed to be there versus what is still important. But I think effective use of SBOM is only, the SBOM is now only part of the picture, whereas maybe previously it was the full picture.
And so with that, and I saw this on one of the slides, how are AI bombs different than SBOMs?
Yeah, and this is definitely a new, well, maybe not new already. It was probably new a year ago, but AI bomb is all over the place right now. And I think it's just a matter of time unless it will become a requirement for compliance. I would say that Europe, they a bit ahead of North America when it comes to AI related regulations, and they are all over it.
Yeah. I mean, at the end of the day, it's still just a bill of materials. It's going to tell you what's supposed to be in there. But with AI, you can have the models that are downloaded, training occurs, code bases change. So I still think there has to be another answer to complement what we've got today.
I think IBOM, aside from binning a report, it's very, very crucial for 0 days because, again, we talked a lot about that, but the response time and the workflows. And if you don't have your SBOM up to date, you don't know if you're impacted or not.
How many here have been vendor management and asked your vendor, what is the bill of materials in your product? Of curiosity. How many here are in vendor management or have asked your vendor what is in the bill of materials of the services delivered or products delivered? And do you incorporate questions around the models themselves for an AI bot? Yeah. Do you ask about what is in the training data?
Yes.
And do you know if there's any material in there, or like, how do you vet the corpus of data present without having read every single line item to say that there wasn't some hidden recipe for a Molotov cocktail or some bioweapon inside there, or some malicious behaviors? Right.
Whether we have the right to use it, whether they use proprietary data, or they have intellectual property there, how it was trained, and more importantly, if they're going to use our data to train the models, part of the onboarding of any new AI application that we evaluate.
Right. So when we're thinking of a supply chain of an AI system, does the standards incorporate the training? Is there a certain framework to describe what can and can't be on there when the corpus is just a natural language? how do you include every single part of that system that goes into a training a model and building it, and the weights that go into it, the algorithms into a certain distributable document.
I don't think we're going to that level.
That builds on the next question. How do you verify supplier authenticity beyond certifications?
Cryptography.
Yeah.
Right? You sign it, you test it. There's plenty of algorithms that cryptographically enforce certain bounds.
Yeah, there's a lot of things along those lines that work, and the idea of never trusting and always verifying is probably the way to go there. I mean, I think of binary analysis. You know, you get an SDK from a vendor, you can go through binary analysis and determine what it's built of, and if they're complying or obliging by the terms that you gave them, and then vulnerabilities you can put in them. If you have the terms in your contract, hopefully, that you can. Some people don't.
So part of it is making sure you have the right contracts in place to hold them accountable, right?
Exactly, and
Yeah.
I've seen contracts where they say we won't fix vulnerabilities.
Right.
That's a bad contract.
Or on the other hand, when you're dealing with very large vendors
Yes.
and you're not the biggest fish in the pond,
Yeah, you're not a.
how do you
priority.
get their attention, right?
Yeah.
Yeah. Okay, this is really good. Okay, now it's your turn. Anybody have questions for the panelists?
There is a question over there.
All right.
Thank you. So with all the challenges that y'all have talked about, the accelerating pace of AI risks, supply chain risks, all that, what do y'all see as the role of like application security practitioners or engineers over the next 1, 2, 3, 4, 5 years? Are they going to be running the scans and tossing them over the fence, taking a different kind of role? How do you see them playing in an organization?
So I personally, I think my time as an AppSec engineer was deploying tools. I'm really happy to say I don't see that in the future for you. I think vendors are figuring out that you need to deploy easy and you need to deploy automatically and then deploy policy. So it's going to be more chasing the vulnerabilities for a change and, you know, using those additional systems that help you determine exploitability.
Yeah, I think it's funny to hear where it was versus where it's headed. I think the idea is that they move from maybe being relegated to mostly pre-production. It's not entirely true, but I think AppSec typically lives pre-production is where they're generally doing a lot of work. I think we're going to see them move to production for the most part over time. I think simply solely pre-production just doesn't work as well anymore. Like when we talk about the dynamic nature of the flow of code and everything. And I think the second thing is that we're actually going to shift from, I think we'll see more of a focus on the techniques that underpin CVEs. Like take JNDI injection, we brought up Log4j a couple of times today. That's eventually what it tried to take advantage of. It's JNDI injection, this individual technique. There's 30 or 40 other CVEs that have spawned from that. So my idea around that is that if we focus instead on the techniques rather than individual vulnerabilities, we actually take care of entire swaths of issues. And you can do that in a production environment. You can't do that as easily pre-production. Running applications, I guess it doesn't have to be production, test, dev, stage, whatever.
Yeah. What Jay said is hit the nail on the head, right? When you're thinking about scale, you have to think at a higher order or a higher level of abstraction. There's a certain alignment around a bunch of CVEs that say is exploiting this particular component in this particular header. Maybe you can solve, 12,000 certain endpoint issues by adding a WAF, and that becomes a part of your toolkit. And not just as an engineer, but I think everyone lives at a higher level of abstraction. Engineers should become managers of agents or as an architect of a system as opposed to just a standard security,
Yeah, they're going to be more facilitators and integrators of the different tools to get at the objectives, right?
With
that they
less
want to
time spent
achieve.
setting them up ideal.
Right.
Like
Less time setting them up and more time optimizing the behavior across and letting AI do most of the heavy lifting.
Right. But still having the skills or capability to go at low of a level as you need to. Just like how no one's coding in assembly language anymore, typically not. Everyone's moved up to typical programming language, and now everyone's moved up to natural language. It's that higher order of abstraction, be able to navigate up and down the stack to understand where a bug enters or where a security gap is in a system.
So going back to the Mythos scenario, how do you address the risk, the remediation delays in terms of patching, right? So when you're depending on third-party systems and patching, and those patches being available, and you're anticipating Mythos types attacks, and you're dependent on the vendor to provide those patches, I mean, how do you solve that?
So I don't know if there is a solution to that today. I don't know if that's a good solution, but what I do see some companies start doing is that they basically patch it. They kind of break the idea of being open source by doing privately and applying the fixes they do on their own. If that's a good approach, if I agree with you, probably not.
More like a workaround until they get the final patch, right? Right.
Exactly. And I think maybe that's where the AI, the same AI in the future will play a major role. And maybe we'll not need to rely solely on the maintainers anymore, or the same maintainers can rely on the AI in order to move faster versus what we do today.
That's good.
I mean, that's a really good point. I didn't think of it like that, but my brain immediately went to like runtime detection type capabilities, or being able to, modern day WASP or even a next gen WASP, where it says, we know this vulnerability exists, help us block it in some manner. I think that's a lot easier said, and that's, I think, maybe a true next gen idea. I don't think anybody has anything that can do that, but you need runtime capabilities to truly solve a problem where if you don't have the source code and you're waiting for a vendor, you can't. Like, you need to protect yourself. So generally detection and creating rules that say we've seen this issue getting triggered and block it. But a next level is trying to block it through like a next gen lab or something like that. Especially if you can do that, especially if you're able to focus on the techniques. So the idea of being able to block based on techniques will be really important there. So, if you've got Java deserialization, Python deserialization, whatever it might be, the ability to look for those techniques, understand how the application is meant to function, how the language that's powering the application is meant to function, and then being able to block on those things, or detect and block on those things. Then it doesn't matter whether it's first party, third party, in between. Then you can look at it from that perspective for runtime.
All right, good. Other questions? All right, let's give our panelists a break and get some drinks and network, right? Just bear with us a moment. We're just returning microphones and stuff. Good job. Thanks. Right. Ari is going to talk about future meeting topics and get some votes on these.
Topics that we have here, we have quite a few categories such as post-quantum computing, AppSec futures, AppSec metrics, ransomware, application security, posture management solutions, women in AppSec, and Mythos blasting defense strategies. So if anybody has any suggestions, anything that you guys might want to hear in the future, these are all for y'all. So it's whatever. We would like your feedback. But yeah, any votes on post-quantum? 3, we have metrics. AppSec futures. 1 for AppSec futures. AppSec metrics. Oh, yeah, you had 1, 2. Ransomware. 1. Application security posture management solutions. 3 over there. It looks like we have a tie for one right now. Woman in AppSec. We got one over here in Mythos glassing defense strategies. Okay, that looks like a winner. Yep, and that's it. And then also call for papers for any future presenters. Yeah, but it looks like Mythos glassing defense strategies kind of took the lead there.
But are you covering the membership too?
Yeah. Oh, yes. Donna, do we have any virtual votes? Was okay, gotcha. All right, and then we have membership here. Right now, we're showing you guys the metrics of our memberships that is clearly growing. Right now, we're at 584. So please tell your guys' colleagues that we would like your support. We would like to have you guys for lunch all the time here for quarterly basis. You know, Scoozy is a great restaurant and get some great speakers here for y'all and learn a lot. But thank you guys.
Spread the word, guys.
Yeah, spread your word. Add it on LinkedIn, tell your colleagues, anyone in a security professional environment, bring them in.
All right. Hi, I'm Dana. These are just some other local security events we have here in San Antonio. Coming up in July 16, ISSA has their Top Cove Social event. Then we have 2 events for ISACA. One, July 22nd is their next chapter meeting on networking. July 31st, they have a joint meeting with IIA on AI and analytics in internal audit. Then our next tentative meeting is September 18th. So that'll be OWASP's chapter meeting. And then lastly, August 18th, ISA has their chapter meeting on geopolitical cyber threats. All right, and this is just a reminder to sign in. That way we have your information to get you guys your certificate of attendance, and these are good for 3 CPE hours. All right. Door prizes. There you go.
Soon, let's do some more raffles.
Thanks so much. Great time.
We got a meter electronic wireless thermostat for your grills.
All right.
That's
wireless
actually really cool.
thermostat. All right. So let's see what we got here. All right, man. 471 339 2. All right. We got one more to raffle here. Does anybody like to go to Hawaii? We don't have that prize, but I was just curious.
We got another tablet.
Another
Tablet X10 RF Pro.
Looks pretty nice.
Yeah.
All right, let's see what this is. Okay, 471 3401. Oh. Didn't you already win some? All right, and with that, let's go to this next slide here. It's time for networking. So join us on the patio here. The waiters will be around to take your drink orders. Say hi to our sponsors. Find out more about their products and services. Look forward to seeing you in a few minutes. Thank you very much.